I would like to take you through a couple of slides that I prepared. I chose a very provocative title for my session. I'll let you think and mull about why I chose it while I'll go through my slides, but the topic is called ReJSON. And the first question you need to ask yourself is, what do Chuck Norris, JSON, and Redis all have in common? The one thing that they all have in common is they're everywhere. Sorry about that Chuck Norris thing. I've been going through a Chuck Norris moment. He's been here, by the way, but it wasn't related. I didn't know about it. And going on about JSON specifically, I don't know if you've heard about coding horror, a guy called Atwood, and he coined this law. It's after the law of power. And basically, Atwood's law states that any application that can be written in JavaScript will be written in JavaScript. And we're seeing a lot of evidence that this law is actually true. I've actually seen Redis run inside the browser in JavaScript. Someone used the cross compiler, so everything is possible. And if you follow that, there's a corollary that immediately follows, is that any database that can store JSON will eventually actually store JSON. And Redis itself does not store JSON very well, or as my friend and colleague earlier acutely or astutely mentioned and observed, this sucks. And why does it really suck? I want to go just a little bit deeper into that and show you exactly why it sucks so much and so hard. It's not that it's bad, it was great, but now we have modules, so we can say it sucks. There were two main approaches to doing Redis and JSON, or JSON in Redis, before we had modules. The first one was just using Redis for what it's really amazing for, just storing blobs of data and fetching them, just like any other cache or a very, very performant in-memory database. So you could take your JSON and just shove it into string keys and then just read it. And Redis does this amazingly fast. No one can compete with that. So you can store raw JSON strings inside Redis's string keys. And you can even go a step further and start using stuff like Lua to manipulate the JSON objects and work with them. And I'll go into a little more detail about that soon. The other option you had is decompose your JSON and store it using Redis's core data structures. I'll show you what I mean in a minute. Let's see a demo, a real live demo that I recorded that shows how you can actually take raw JSON strings and shove them down Redis's throat. So you do a set, you take a key, let's call it raw JSON, and then you just put the entire string into it, the entire JSON. And if you want to get that JSON, there's a command for that. It's called get. You just get it, which works great. There are several advantages to that. And by the way, guys, if you want, the presentations will be made online, recordings of the videos will be uploaded. I'll email the entire lot of you, so please concentrate instead of taking photographs. All right, so the advantages is that the data is stored as is, it's serialized. There's no extra work needed to fetch it. I just need to read it. It's perfect for opaque caching of blobs. If I don't care about what's in the JSON, if I don't want Redis to handle the stuff in the JSON value, that's the perfect way to go. Also, although JSON is quite expensive in terms of a serialization format, it's still not that expensive to keep that the JSON values in serialized form in Redis. There are, however, a couple of disadvantages. The big one, the major one, is actually the fact that you cannot access the elements inside the JSON. It's just a big blob. We don't know how to get inside, how to navigate it. So if you want the whole thing, good. If you want to replace the whole thing, that's also good. But once you start digging down into the JSON value, this document, you can't really go any further. The other problem with that is if you want to modify the JSON, since you can't do it on the server, it's just a raw JSON, you have to read it in your client, get it to your client, so there's a latency there and there's traffic on the network. And then the client modifies the JSON. It parses it, deserializes it, changes it, serializes it, and then stores it back. During that time, we may lose atomicity. So we read a value, we change it, we write it, but in the meantime, someone else changed it. So you can take this a step further, actually. In version 2.6, if I'm not mistaken, Salvatore added Lua scripting to Redis, and you can actually use Lua scripts to manipulate JSON, because one of the few libraries that are included in the Lua sandbox that Redis provides is in fact a fully fledged JSON library. So this mini script here shows how you can work with it. Inside the script, this is Lua, what you're seeing. You're just reading the JSON, and then you're passing it through this library that's called CJSON. You code decode. It explodes it into Lua's native data type, which is called a table. Then you can navigate it, search for whatever element, change it, and then recode it, or encode it, and store it, or return it, or whatever. And this works pretty well, actually. It works very, very nicely. This gives you a couple of additional advantages to just storing raw JSON. You can actually start accessing and manipulating elements inside the JSON, because CJSON, the library, can unpack it or decode it and encode it at will. The updates are atomic, because Redis Lua scripts, for those of you who don't know, are atomic. So they're run in their entirety. So any changes I make in them are safe. And I can even switch from using JSON to using something called message pack, which is a little bit faster than JSON and also cheaper in terms of the memory overhead. There are disadvantages, of course. There are no free lunches. The disadvantage is that as my data grows, as the size, the length of the value grows, so does the access time to the elements. I need to spend more time deserializing the JSON, spend time searching for the elements, and then spend more time re-encoding the entire thing. And although I love Lua, I've made half of my career on Lua, there are people who don't really grok it. There are people who don't want to learn it. And Lua isn't for everyone. If you're a Ruby developer or a JavaScript developer, you shouldn't be forced to pick up Lua and then maintain more code, more scripts, just to make something as basic as JSON value. The other approach I mentioned earlier is basically take your JSON value and decompose it. A JSON is basically could be thought of as an object. So we know how to mimic objects or model objects in Redis using hashes. And we've got lists and strings and all that good stuff. So just decompose it. And it works up to a point. The point is, well, let's talk about the advantages, because this is the format I adopted. So advantages. Once I have that, I can access every element in the hash in predetermined, fixed, constant time, what's called O1 time, O1 complexity. The disadvantages, however, are numerous. This translation between hashes and JSON isn't done automatically. You have to perform it yourself, at the client perhaps, or perhaps using Lua, but you need to code for that. It's not automatic, so every time you need to get back a JSON reply, you need to go and assemble the entire hash and convert it to JSON. And Redis, despite its richness of data structures in terms of native core, very basic data types, only does string and a sort of a number. So that's not really what JSON wants, but perhaps the most problematic aspect of this approach is the fact that there's no nesting. You can't do nesting with Redis's data structures. So this approach basically works only for flat dictionaries. And that was the case up until a year ago, basically, where until modules became a real thing. ReJSON is a very witful and innovative play of words on Redis and JSON, in case you've missed that. I did a poll on Twitter, asked for other names that nobody gave them, so we're working with this right now. But what is ReJSON? It's basically a module. You've heard about modules today. So modules, the next best thing, the way to expand and extend Redis even faster then Salvatore is coding it. I don't have to wait for him for his Redis. I can do whatever I want in my code and run it in Redis. So ReJSON is exactly that. It uses the custom Redis data type API in the modules. So I create my own data type just like any other data type in Redis. And I can store in it any JSON value. JSON has a couple of values like scalars, which are strings, number, booleans, the null value, objects, arrays, nested or unnested. Everything goes with ReJSON. It just eats JSON for breakfast, lunch, and dinner. The data itself is not stored like I showed you earlier. It's not stored in its raw serialized JSON form. It's actually stored exploded, decomposed in binary form in RAM. And we provide a JSON-like, JSON path-like syntax for accessing the elements. I'll show you that in a second. Let's move on. So, I like demos. Here's another demo. How do you use ReJSON? Once you've loaded ReJSON, the module, you get a set of commands. All of them start with the prefix JSON period or JSON dot. And then you got your set command, which basically gets just the key name, then a path inside that key. Since I'm creating a new key now, I'll need to give the root path. So I'm just giving this period there, saying this is the root. And then I shove down a JSON value. The first example is that of a string. So it's a scalar string. I'm saying hello JSON. So scalar will contain a string that says hello JSON. Then I go and push my luck and I do an object, a whole object with just a couple of fields in it. One of them is a string, the other is a number. Again, Redis says okay. You see, everything succeeds with this module. And then I can do get. And this is the nice thing. Once I do get, the first time I do get on the entire object. It looks almost exactly identical to the raw JSON, but there is a difference here. It's not the raw JSON. Notice I put here a space, all right? And the space is gone here. That means this is my way of telling you, look, I've processed it and it's not what you've put. It's reconstructed. And I can actually go and take parts of the document using this JSON path-like nomenclature, saying dot answer or dot ans and get just one part of the document. But I can even go further and make it much more pretty if I press the next button. So as you can see, I exited my Redis CLI and I ran it in a special mode called --row, which basically prevents Redis CLI from escaping special characters, and then I can tell ReJSON how to prettify my output, and then you get your nice indented JSON object right there. The idea, the core concept is very, very simple. We haven't invented anything new here. JSON looks and smells and is very, very easily transposed or translated to a tree-like structure, your basic tree data structure. So what we're doing is once you call the JSON.set command, we, in the background, intercept that, take the input, assuming it's a valid JSON, we feed it into a component called JSON-SL. We actually didn't develop that. We didn't want to develop a JSON parser. It's sort of masochistic, and other people have done it before us. So we found actually a perfect fit for us. It's called JSON-SL, an open source product or project by someone who's working at Couchbase at the moment. The nice thing about JSON-SL is that it's a streaming lexer, meaning it doesn't actually keep the data that it reads. It just goes through the states and lets me create the tree the way I want it. And I create a very naive tree which starts at the root, has an object under it that has keys, each key pointing to the relevant value. Why would you use ReJSON in your everyday life for storing JSON data? So the advantages of ReJSON are quite clear. They're like almost the exact opposite of the other approach, the orthodox approach. So first you've got your full native JSON support inside Redis. You don't have to work for that. It's all bundled, it's all built in. And it works just like you'd expect JSON support in any other language. We try to adhere to the standards so it will feel intuitive. But on the other hand, everything looks and feels like it's in Redis. Get, set, and you'll see the rest of the commands. You'll see what I'm talking about. The thing is, you can work with it from any Redis client. So no matter where you're programming now, just pick up ReJSON, use the same client you're using now, and call ReJSON's commands, and you'll get JSON support. But ReJSON, unlike the serialized approaches, doesn't require extra time to access by path or have a direct access by path to elements because it's already exploded. There's a clear navigational path for me to walk wherever I need to go. The disadvantages, of course, are the fact that serializing this tree-like structure back to JSON is expensive when I compare it to just fetching a JSON value that's already serialized. There's work to be done there, as well as the fact that my tree data structure has higher memory overheads compared to anything else. We're working to optimize that, of course, but still, it's going to be higher. These are the disadvantages. However, let me try and convince you why you should work with ReJSON with a few benchmarks. This is basically something I've already covered. I don't... oh, there's a joke here. Yeah, that's important. So the fact is that there's no standard for specifying paths in JSON. There are two standards, so there's no one standard. We have to invent our own. We're trying to stick with JSON path, which looks like it's more popular. So why would you use ReJSON instead of just storing Lua, storing row JSON or even message pack? I ran a few tests. They are basically the same tests. I'm just using different sized JSON values. So I started with 300 or 400 bytes of JSON value and fed it into Redis. You can see the blue line is ReJSON. The high on the left side, you can see the rate. So more is better. I'm pushing more operations per second, while lower is worse. On the right-hand side, you see the latency. The latency, you want to keep that low. So you can see that when we're looking at ReJSON as compared to row JSON in Lua and message pack in Lua, you can see that the set value takes considerably more time because ReJSON, whenever you do set, decomposes, deserializes, builds the tree. But on the other hand, accessing everything is much, much faster, and you get much better throughput. Let's make the size a bit bigger. I tried aiming for about 10 times bigger, so 3.4Ks now. You can see pretty much the same behavior. Set is slower because we're working on the value, we're decomposing it, but everything else, once I start digging into the value and fetching values and data and manipulating it, happens a lot faster. And surprise, surprise, even if I go to about 40K per document, I'm still seeing pretty much the same behavior. Just to give you a gist of what ReJSON is all about, so this is like a high level of all the commands that it knows. There are actually quite a few, you can notice. You've got your general commands, which are the get and set, which we saw already. Then there's a del. You need to be able to delete parts inside the JSON. So del accepts a key and a path and deletes everything under it. You got the mget and the type, which tells you the type of value that you're asking inside the JSON, perhaps. Then you got the family of commands to deal with numbers, specifically increment and multiply numbers in the JSON, and this is done atomically, just like Redis's incr by and that sort of thing. We've got our strings operations, we've got object operations, and a whole bunch of array operations for sticking things in the middle, searching for them, removing them, popping. A lot of fun. And the nice thing about it is that it's evolving. When I say it's evolving, right now we're talking about a source code that's available on GitHub for everyone. There's a documentation website as well, so all the documentation is available. We've had a good teacher. We know how to write open source software that's well documented, hopefully. Right now, we're doing the preview release, and the future is filled with promises. Some of them you've heard about. Veer's secondary indexing module is going to be a star in this ReJSON module as well, because we're going to connect them so you can actually index your JSON documents as you insert them into Redis and then fetch and query on them. What really matters is user feedback. We're dying, or actually I'm dying for your feedback. So if anyone wants to take Redis and ReJSON for a spin, I'd really appreciate it. If you've got any feature requests or pull requests, please let me know, and I'd be happy to help you with them. Thank you.